All right, let's do this last question, this last example. Going to do it on another page just because I need to have more space, and I had already wrote some of it out. I was just making sure I was on the right track. I guess I don't need to delete all this. But these questions do have a lot of steps, so it's really important that you follow each of them, or you'll get lost in how to do these questions. So step one is the reaction time distance. So if you look back at the slide before this, we're looking at the reaction time distance. So that's what we want to find out. And when we're reacting, we should be going in a uniform motion. So we should be using d over t, or v is equal to d over t. All right, that's the formula that we're going to use. We need to rearrange it so that we have distance, because we're looking for our distance we traveled during our reacting. And to do that, we would get velocity times time. All right, so if we read through our question, it does tell us right in the very first sentence that our reaction time is 1.5 seconds. And so we have that piece. We just need to know what our velocity is when we are driving. If we read through the question at the very end, it says that the vehicle was traveling at a velocity of 110 kilometers an hour. Great. One huge problem here is that our velocity is in kilometers an hour, our acceleration is in meters per second squared, and our time is in seconds. So what we need to do here is change our 110 kilometers an hour into meters per second. Then we can actually do this question. So there's multiple layers to this question. I'm going to do this over here. So we need to change 110 kilometers an hour into meters per second. If you look back in this slide, topic 1, you will see how to do this if you forget. I always set it up like this. We have kilometers over hours. To get rid of our kilometers, we need to put kilometers on the bottom. To get rid of hours, it's on the bottom, we need to put it on the top. Now, what we're changing to is meters, and what we're changing to is seconds. So that's what we put on either of those. All right. So next we need to put in the numbers. So we got 1 kilometer. In 1 kilometer there is 1,000 meters. And in 1 hour there is 3,600 seconds. That's really terribly written. I apologize. I'm doing a lesson. Is that okay? I'll be right there in a second. Okay, so in 1 hour we got 3,600 seconds. So if we calculate that out in our calculator, which I have just been using my iPhone, you can do this on your phone. We're just multiplying numbers. We would go 110 multiplied by 1,000 times 1, which would give us 110,000. That's on the top. We then multiply out these numbers on the bottom. It's basically 1 times 3,600, which would give you 3,600. In doing that, we can divide 110,000 divided by 3,600, which will give you 30.55. This is in meters per second, okay? that is our velocity. So now we actually have the proper velocity and the proper units. So we can go ahead and actually calculate this. So we're going back to this. So our first thing is we need to find our reaction time distance. So to find that distance, we take our velocity times our time. Our velocity we know now is 30.55. Actually, this is 30.56, just because there's another 5 past that, so this becomes a 6. Sorry about that. Multiplied by our time, which in the question it says 1.5 seconds. If we multiply those two numbers out, our distance is 45.83 repeating meters. Okay, great. That is our first piece of information that we need. So that is our reaction distance. So if we look back to the picture, we need to find out our reaction distance and then our reaction time distance and then our stopping time distance. So we've got one of the pieces. Now we got to move on to our step 2. So step 2 is finding out our stopping time. We need to find out what our stopping time is so that we can solve for our stopping distance. So to find our stopping time, we're going to use this formula. I'm getting these steps from the previous slide. All right, so our velocity, we're solving for t. This is the piece that we are looking for. So we have all the other pieces of information. We've got our velocity final, which if we're stopping, should be 0. 0 minus our initial velocity. So before we start stopping, our initial velocity is this. It's 110 kilometers an hour, and we changed it into meters per second. So we need to use that right here, 30.56. All right. Divided by our acceleration is negative 5.85. Meters per second squared. I should have put meters per second on these. This is meters per second as well. And then if we calculate that all out, we will get our stopping time. Okay? This is our stopping time so that we can calculate our stopping distance. So to do this, we would go 0 minus 30.56 gives us negative 30.56 divided by negative 5.85. And we get 5.22393, a bunch of other numbers. This is our time. Sorry, not time. It is our time, but it is in seconds, so we need to write seconds here. I'm just going to keep some of those digits just because I don't want to round it off yet. You could, it's not a huge deal because we're not going to be rounding anything. It's just going to be taking that because this number is not higher than 5. So we would just have 5.22 seconds. And then we need to do our last step. Step 3 is going to be figuring out our stopping distance. right, so to figure out our stopping distance, we are going to use d is equal to vi plus vf divided by 2, and then this is all times t. All right, so we've got to figure out stuff inside the brackets and work our way out. So let's do this. This will be our second last step. So our stopping distance is going to be our VI. Remember, our initial velocity is what we calculated as being 30.56, because that's in meters per second, plus our final velocity, which is 0 because we're stopping, all divided by 2, and then multiply all of that by t, and we figure that out as being 5.22 seconds. Okay, so now if we calculate that out, we should get our stopping distance. So we go 30.56 plus 0 is 30.56 divided by 2 gives us 15.28. Okay, so I calculated everything inside of those brackets, and now outside of the brackets is 5.22. So I'm going to take my 15.28 and multiply it by 5.22, and I get an answer of 79.7616, and that is meters. We're almost done. Almost. Now we need to go back up here, find out our reaction time distance, which is 45.83, and then add these together. 45.83. Is that right? It is. So 45.83 plus, so I'm sorry, I should put step 4, is add so we're going to add both the distances, so I should write this in a better way. That's meters plus 79.76 meters. And if we add those two together, we will get our total stopping distance, or yeah, stopping distance. So adding those together, I get 125.59. That's meters. So if I'm going 110 kilometers an hour, it'll take me 125 meters, give or take, to stop, come to a complete stop. So think about that when you're driving on the highway. You're normally going around 110, that's the speed limit at least. If you're going faster, it's going to take you even longer to stop. So this is your total stopping time distance. So that's quite a big amount of space that you're going to need to stop. This all depends on, I guess, how much you press on the brakes as well. But for this question, that's how they were stopping. Okay, so that's the end of topic 1, unit on physics, and we will continue on topic 2 of physics next week. You're responsible for the review questions that you have for this, and if you don't have your topic 2, you can come and pick it up at the school on Tuesday. They'll be available in the gathering area. All right, Have a great weekend.